In this video, we will be discussing domain and range. So we introduced these topics in section 3.1, but we're going to go more into detail about these in this section. So this corresponds to section 3.2 from the free college algebra textbook at OpenStax. So first, what we want to do is find the domain of each function using interval notation. So remember that the domain is the set of x values. So it's all the possible x values for a given equation. So for number one, we have this function given. What you're really looking for here is x values that are going to be problems. For example, if you have a fraction like 3 over x, we know that x cannot be 0 because you can't have 0 in the denominator of a fraction. Otherwise, x could be anything. So in this case, your interval notation, in order to say x can be anything except 0, would be given in this way. So x can be between negative infinity and 0, not including 0, or x can be between 0 and infinity, not including 0. So that's the way to leave out an endpoint. So if you don't want to include a 0, in this case, 0 is your endpoints. You use the little union symbol, the U in between, to show that you have more than one set included in your solution set. And then remember, negative infinity and infinity always get parentheses. Okay, so we're looking for exclusions. So for number one, we don't have any exclusions. Here's what you're looking for. You're looking for a fraction because you have to exclude the numbers that would make the bottom 0. And we're looking for a radical symbol because if you have a square root, what's under the square root has to be non-negative. So those are our restrictions. If we don't have a radical or a fraction, that means we will not have any restrictions. So in the case of number one, we don't have a radical, and we don't have a fraction, so our domain is all real numbers. And to indicate that using interval notation, we say that it's between negative infinity and infinity. Number two, we do have a restriction. We have a radical. So what's under the radical has to be non-negative. That means it must be greater than or equal to 0. So we take what's under the radical and set it greater than or equal to 0 because that's what we want to happen. And then we solve that inequality. So we add 2 to both sides. We get x is greater than or equal to 2. That is our domain. So now we just need to write it in interval notation. If it's greater than or equal to 2, that means it starts at 2 and includes 2, so we use the square bracket, and then it goes to infinity. So that would be our domain using interval notation. Okay. Notice I didn't care about the 3 on the outside. I'm just worried about the restriction. All right, number 3, I want to find my domain. Let me just scroll up. 3 and 4, you can see that both of these have fractions. So our restrictions here are, remember the denominator or the bottom cannot be 0. So I'm going to take the bottom and set it equal to 0 and solve. And that's what I have to exclude from my domain. So I will get 4x equals negative 2, divide by 4. So x is, if I reduce that, negative 1/2. This is my exclusion. X cannot be negative 1/2. Because if I plug in negative 1/2 in the denominator, I'm going to get a 0. And I don't want that to happen. So that means I can use anything else I want for x except that one value. So to exclude a value, you go from negative infinity to that value with parentheses, union that value to infinity, just like I did in that extra example I did at the top. Okay. Number 4, again, we see that we have a fraction. So we don't want the denominator to be 0. So I'm going to set it equal to 0 and solve and see what will happen. So x squared minus 2x minus 15 equals 0. Notice that I have x squared. That means this is a quadratic equation. So now I'm going to solve by factoring. Remember, if it doesn't factor, you could use the quadratic formula. So x and x, what multiplies to get negative 15 and adds to get negative 2, that would be negative 5 and positive 3. And now I can set each factor equal to 0 separately and solve. So if you didn't realize until now, or maybe you still haven't realized or thought about it, we're going to have two answers here. That means we have two things that x cannot be in this case because we had a quadratic in the denominator. All right, so x cannot be 5 and x cannot be negative 3. So we need to leave out both of those from our interval notation. All right, so first you want to identify the smaller of the two numbers. So negative 3 is the smaller of the two numbers. So we're going to leave that out first. So we go from negative infinity to negative 3, union negative 3 to the other one we want to leave out, 5, union 5 to infinity. So again, you can see that each number we're leaving out is hugging the union symbol, right? And so for every single x I find that I have to leave out, I'm going to add one more interval into my answer. So here is my domain. All right. Number 5. Now we're going to write the domain and the range from a given graph. Now here is the key to this. It seems really easy, but it's so easy to make a mistake. So first of all, you want to make sure you realize that the domain is the x, range is the y. Okay, I'm going to do these in separate colors. So first, the domain. Domain is the x values. So what you want to do is you want to look down on the farthest left and the farthest right and look at where those points are. That is your domain. Your domain goes from 4 to 8. So there's a point everywhere between 4 and 8 on the x-axis. So your domain is 4 to 8. Notice I used the square bracket on the 4. That's because there's a solid circle there. And I used an open circle on the 8. And that's because there's an open circle there. All right, let's look at the range. So the range is the y values. That means I'm going to look at the y-axis. So this is always bottom to top, okay? You always have to put domain and range, since they're in interval notation, from least to greatest. You can't put it the other way around. So for example, on the domain, if you would have put 8 to 4, that would be wrong because you have greatest to least. It has to be least to greatest, okay? So that's not correct right there. All right, so range is bottom to top because it's the y value. So the bottom point is here. That corresponds with a value of 2. Since it's an open circle, I'm going to have parentheses 2. And then the very top I see on the graph is this dot, so it's going to correspond to 8. It's a closed circle, so it gets a bracket. All right, let's look at the next one. So same thing, domain and range. So domain first. Remember, domain is left to right because that's smallest to largest. So the leftmost dot or value I see is here. That corresponds to an x value of 2. Since it's a closed circle, it gets a bracket. The furthest right I see is this dot, and that corresponds to an x value of 6. Since it's a closed circle, it gets a bracket. And that's my domain. All right, now let's look at the range. So the range is bottom to top, okay? Here is the lowest value that I see. That corresponds, and these should all be negatives. I don't know why there are not negatives. Otherwise, that would not make sense. Okay, so this corresponds to a y value of -6. Now there is no dot there at the bottom, right? I just put a dot. But from the graph, you're assuming that it reaches the 6. So you're going to use a square bracket, that -6. And then the top point I see, there's actually two of them at the same point, is right here, right? And that corresponds to a y value of -2. And that would also have a square bracket. Okay. Number 7, domain and range. So if you feel like you have the hang of it, pause the video, try it yourself, check your answer. Okay, so the domain, left to right. So the leftmost value I see is this dot down here. And that corresponds to -3. The rightmost value I see is right here on the 2, right here. It's an open circle, so it would be a parentheses. Left to right. Okay, range is bottom to top. So the lowest point I see is way down here at the bottom. And that corresponds to a y value of -5. Okay, and now the top value. The highest point on the graph is up here. And that's at a y value of 4. So -5 to 4 is the range. Okay, so again, domain, you're looking for the leftmost value and the rightmost value. The range, you're looking for the bottom value and the top value. All right, number 8. So the domain is x. Now, notice I have 2 pieces on this one, right? I have 2 pieces. That means you're going to have 2 parts to your domain because you have 2 pieces. So actually, let me write the domain up at the top where I have plenty of space. Okay, so domain, left to right. So it looks like it stops at this point right here. This is the furthest left it gets, and that's at -6. And then this part of the graph goes all the way to here. And you can see that is associated with the x value somewhere right in here. So maybe we can say -1/3. And it is also a bracket because it was a closed circle. Okay, so now, and on this, let's say you had one like this on the test. If you can give us a good estimate of where that is, that's going to be acceptable. If you said -5, then clearly that's wrong, right? But if you can tell us it's a fraction between 0 and -1, and you estimate -1/3 or -1/2 or anything like that, that would be fine. Okay, so now I need to put a union, and I'm going to put the interval notation for the second part of the graph. So it looks like it starts here. This is the leftmost value of this part of the graph. And I would say maybe 1/3 or 1/4, something like that. So 1/3. And then it goes all the way to here, and that is associated with 6. All right, so there is my domain. Okay, now let's look at the range. All right, so range, remember that's bottom to top. So I'm going to start with this left piece. The bottom value is here, so that's associated with a -6. And then it goes up, right? It keeps going up until I get to this dot. And that looks like it's about -1/3. Okay, and now the other part I'm going to do bottom to top. So this bottom, this is the lowest point I see on this graph. Looks like it's about 1/3. And then the graph goes up, and this is the highest point I see on that part of the graph, and that's associated with the value of 6. Okay, number 9. So domain and range. So for the domain, we're looking from left to right. So if I go all the way to the left, the furthest left point is here, so that's at -3. And then the graph continues on and it has an arrow on this end. That means it goes forever in the right direction. So that'll be infinity with the parentheses. Okay, so you're only going to have an end point if there's a dot at the end. If there's not, if there's an arrow, then you're going to have an infinity. The range, remember, is bottom to top. So the lowest point I see is here. And remember, you're looking at the y value. So the y value it's associated with is 0. And then for the range, it goes up. Again, there's an arrow at the end, so it goes up forever. So you have an infinity. All right. 3.2, I'm going to need to make this a little bit smaller so that we can see the graph at the same time. Okay, I think that's good. So this one, we want to sketch a graph of the piecewise function and then write the domain and range in interval notation. So notice here for number 10, we have f of x equals, and then there's two different options. F of x equals x plus 1 if x is less than -2. But f of x equals -2x minus 3 if x is greater than or equal to -2. So you can see they're both compared to -2, right? The first thing I always do is I always go and separate my graph into two parts. So I know it's going to be separated at the -2. Okay, one thing happens if it's less than -2, and another thing happens if it's greater than or equal to -2. All right, next what I want to do, oh shoot. All right, next what I want to do is highlight the two different cases. Okay, so f of x is equal to x plus 1 if x is less than -2. So that is this way, on this side, the left side of the graph. So y equals x plus 1 if it's on the left side of the graph, because that's the values that are less than -2. Okay, f of x is equal to -2x minus 3 if x is greater than or equal to -2. So that's going to be on the right side of the graph. Y equals -2x minus 3. Okay, so now what I need to do is graph these lines and make sure they only are occurring on the appropriate side of the graph. So for the red part, I have y equals x plus 1. To graph a line, remember you start with the y-intercept. So the y-intercept is 1, so that would be here. And then you go up and over according to the slope. So the slope here is 1. So 1 over 1, that means you go up 1, right 1, or down 1, left 1. Now this red is only supposed to happen on the left side of the blue line. So these dots that I've drawn actually are not even appropriate for the graph. But I have to get it started somewhere. So what I would suggest is using a pencil and start it like you know how to start it, and then just draw the dots in the correct direction. So for example, it wouldn't be appropriate for me to keep drawing dots up and to the right because that's not on the correct side. So I would keep going down 1, left 1, okay? And then I want to connect those into a line. Now, the key here is to remember that it said x is less than -2. That means it's not going to be included on the -2 part. Okay. So I want to erase all the red dots on the right side of the blue line. I want to make this be an open circle. And then I want to connect these into as straight of a line as I can get here. And that is the red part. That is the first equation in the piecewise defined function. Now I'm going to do the same thing for the green. So the second part, this y equals -2x minus 3, I have the y-intercept is -3, so that will be down here. And then I have the slope of -2. So the slope is -2 over 1. That means down 2, right 1, or up to left 1. Now this is a greater than or equal to, so I will have a solid dot on that blue line. And then I'm going to connect these in as straight a line as possible, and that is that side. And that's it, okay? So make sure you realize that what you're doing is splitting the graph in half, and you're just graphing two separate pieces on the same graph. That's why it's called a piecewise defined function. You have two different pieces on the same graph. Now, you're going to have a domain and a range. So your domain is left to right, and it's the whole graph they're looking at. So the red part goes from negative infinity to -2, but then the green picks up at -2 and it's included and it goes to infinity. So your domain is covered everywhere, okay? Even though there's a split in the graph, there's no numbers missing. One picks up exactly where the other leaves off. So that's their domain. Okay? Your range, they both go down to -infinity. And then the highest point is this green dot, right? This is higher than the red. So the highest possible point on the graph anywhere is 1. And it's a closed circle, so you get a square bracket. Okay? So that's your domain and range. Okay, number 11. So again, we have a piecewise defined function. The first thing you should do is split your graph into two parts. So you want to look and see what you're comparing to. So you're comparing to 0. So when x is 0, that is going to be the vertical line right through the middle. It's the y-axis. So that's going to split your graph into two pieces. Okay. So now you're going to have your top piece, which corresponds to x is less than 0. So that will be on the left-hand side. Okay. And then you're going to have the second piece, which is 1 minus x, which corresponds to when x is greater than 0. So that will be on the right-hand side. Okay. What's on the left is a quadratic. So we talked about the toolkit functions in 3.1. So you should know the basic shape of that. And that is a toolkit function. There's nothing happening to it. So if you don't know the points yet associated with this graph, you can try an XY chart. So you can make an X, then you can make a spot for you to show your work, and then you can make the Y part. So X, if I make X be 0, I have X squared, so 0 squared, that's 0. So 0, 0 is the first point. Since it says up here X is less than 0, no equal to sign, that means that I have to put an open circle there. Now, when you're choosing values for your x, remember that you want it to be on the left-hand side of this yellow boundary line. So you should choose things like -1, -2, not positive numbers because that would be on the wrong side of the graph. So if I choose -1, I will see what -1 squared is, and that's 1. So -1, 1 is another point. All right, let's pick -2. I have to square that. -2 squared is a positive 4. So -2, 4 is another point. And I'm going to choose -3. So -3 squared is a positive 9. So that would be up here. Okay, and now you can see that it's not a straight line. We shouldn't expect it to be. It's a quadratic, which means it's kind of like a U shape. Okay, so there's the red portion of the graph. Okay, now for the blue, notice that it is a linear equation. So this is going to be a line. So to graph this, you're going to start by looking at the y-intercept. Now, if it's throwing you off, the order is different. You could rewrite this as y equals -x plus 1. Just rewrite it so the x is first. And now you should be able to see that the y-intercept is 1. So that would be here, right here. It's an open circle because x is greater than 0, not equal to. So you got to have an open circle on that boundary. And then you're going to use the slope. So the slope is -1, which is like -1/1. So you can go up 1, left 1. That'll put you over here. That's not helpful. Or you can go down 1, right 1, and that puts you on the correct side. So down 1, right 1 is how we want to go, because that's going to give us the correct side of the graph. Connect those. This should be a line. And there's your piecewise defined function. Okay, so let's talk about the domain and range this time. So the domain is left to right. So the red portion goes from -infinity, and then it goes until 0. 0 is not included. The blue portion starts at 0, but notice that neither of those are shaded in. They're both open circles. That means 0 is not included. So I'm going to have to leave it out. Okay? And then the blue goes from 0 to infinity. So again, the reason this domain has two parts is because neither of those circles on the boundary line are shaded in, because I had no or equal to in my if statements above. And then the range is going to be bottom to top. So the blue goes from -infinity to 1, and then the red goes from 0 to infinity. They overlap. So all of the values are covered in one or the other graphs. So you're going to have -infinity to infinity. Okay, let's see. This is the last one we have for piecewise defined functions. So we're going to look at the boundary points, but notice this time the boundary is not the same. So we're going to have two different pieces. So first of all, we have if x is less than or equal to -1. Okay, so that's going to be over here. So y is equal to 2x minus 3 if x is less than -1. So that's to the left of that yellow line. Okay, now I have greater than 4. So that's here. Whoops. That's here. Greater than 4 is to the right of that. So to the right of that, I will have y equals the square root of x if it's to the right of 4 for the x values. All right, yellow, or the stuff at the left, is a linear equation. So we're going to graph that as we know how. So we have -3 is the y-intercept, and then the slope is 2, so it would go up 2, right 1, which is not helpful, or we'd go left 2, down 1. Okay, here on the boundary point, it's going to be an open circle because there's no or equal to sign. And we'll just keep going down 2, left 1. Okay, and so here's our line. And then we want to make sure we erase the parts on this side, right? All right, and in the red, we have a square root function. So we're going to have to either have memorized the points, or we can just pick x and y's. So for x, okay, I want to pick the 4 because that's a boundary point. So if I pick 4, I have the square root of 4, which is 2. So 4, 2 would be my first point, and it's an open circle because there's no equal to sign underneath it. Then I want to pick, like let's say I pick 5. Well, 5 is not going to be helpful because I don't know what the square root of 5 is. So I want to pick something else that's a perfect square. So the next thing on my list is a 9. That's the next perfect square. The square root of 9 is 3. So 9, 3 is another point. So it's going to go kind of like, whoops, kind of like this. And if you remember, this is not a line, although it kind of looks like it for my drawing. It's a sideways U, okay? Notice that there is a whole chunk of the graph here that is empty. Okay, this is not included in either of the sets, and that's okay. We just have to leave that part blank. Okay, so now we want to give the domain and range. So the domain, I'm going to have two distinct parts. I'm going to have the yellow and the red. So the domain is left to right, so it means I'm going to start with the yellow, and it goes from negative infinity until -1. Okay. Union, the red part is 4 to infinity. Okay, and then the range is bottom to top. The lowest I see is the yellow, so I'm going to start there. So it goes from negative infinity up until here, which is -5. And then the red starts off here at 2, and it goes to infinity. All right, we only have a couple more. So given the function, evaluate for the given value. So here they're trying to see if you can understand how plugging these numbers in work if you have a piecewise defined function. And once you figure it out, it's really not that difficult. So the -3, what you want to first do is see which case it corresponds to. So remember that this is the x value. So x, here on the top, I have x is less than 2. X is less than -2. You use the top case. And if x is greater than or equal to -2, you use the bottom case. So your goal here is to figure out, is -3 less than 2 or is -3 bigger than 2? So -3 is less than 2. So that means that you would need to use the top case. Okay, so you're going to use the top case because -3 is less than -2. That means you plug it in to the top equation. So you'll have -3 plus 1, and -3 plus 1 is -2. So your answer is -2. Okay, part B, -2. Well, -2 is, you have to use the one that has the or equal to sign under it. So -2 is greater than or equal to -2 would work. So that would be the green. So you're going to use this equation. You're going to plug in the -2. So -2 times x, which is -2 in this case, minus 3. That's going to be 4 minus 3, which is 1. So your answer is 1. All right, -1. Is -1 less than -2? Or is it greater than or equal to -2? -1 is greater than or equal to -2. So again, we're going to use the green. So we're just going to plug it in. And we'll get -2 times -1 minus 3, which is 2 minus 3, which is -1. All right, 0. 0 is greater than or equal to -2. So that's again the green. So we're going to plug in the 0. So -2 times 0 minus 3, that's 0 minus 3, which is -3. So the key here is just deciding which case you need to use. All right, number 14. Let's make this one be red. This one is blue. And this one is green. Okay, so g of -1. So we need to figure out, where does -1 fit? So we have, it could be less than 0, between 0 and 3, or greater than 3. So I think we'll agree that the -1 is less than 0. So we're going to be plugging it in the first equation. And so we have 5 times x, so 5 times -1, which is -5. Okay, next we want to look at 0. 0, we're going to have to use the blue case, right? 0 is greater than or equal to 0, so that would work there. Whoops. So this is blue, the second case, right? All right, so we're going to plug it in. There is no x, so the answer is just 3. Okay, now we have g of 2. 2 is between 0 and 3, so 2 is also a blue case, and that means the answer is just 3. Okay, then we have g of 4. 4 is greater than 3, so that is the last case. Whoops. That's the last case. So we're going to plug in 4 in the last equation. So 4 squared is equal to 16.